Alright, hello everybody, welcome back. Carl again. Today I want to work on a repair of a Lionel 6-12867 PowerMaster. I bought this on eBay. As soon as I got it in, I applied power and it didn't work. I didn't get any status LEDs. So I took it apart and I went looking inside here, and this is what it looks like inside the case. And I noticed that there was no power to these grounds, or to these poles here. So I flipped this over and I noticed that on the back there's these two solder points here that tie these two boards together. All this side had solder, this front row. This tab had solder, that tab had solder, but this one did not. So I thought, well, that's odd. It looks like it's supposed to cross there. And what this is, this from here to here is a resistance wire. And this is how they're measuring, I don't think you're going to be able to see it, but down inside there, I'm just going to get a little light on it. Down inside, you can just see that silver part. That's a resistance wire. And they use that to, there's another shot just below those capacitors. They're using that to measure the amperage so they know how much amps are coming through this PowerMaster. Now, the newer ones, the 6-12, I believe it's 430, has a little switch on the front. And they've actually now added two resistance wire. You flip the switch and it lets you select between 135 watts and 180 watts. Nevertheless, that doesn't make a difference for the purpose of this. This one is strictly the 135 watts, so you have one resistance wire. Now one thing that I don't realize, I don't know they did, they have a spot on there for VR2 or varistor, and that basically clamps the voltage down. And I don't understand completely what a varistor does, but it helps with those voltage spikes. And in the case of a model train, if you have a derailment, that'll help stop those spikes. So anyhow, I found this great website, which I'll link in down below, trainfacts.com. And the gentleman there, he has went through and kind of drawn out schematics. So I actually have some schematics from him. And he also has a little theory about how it works. Nevertheless, it gives you an idea of how it works. And then this is the full write-up. So I went to his website and I started looking at possible solutions. So down here, he talks about a couple problems. Now, Lionel has talked about in some of their videos that they actually use what's called a sync pulse every time that the frequency shift changes. So an alternating current, it changes its polarity from AC to DC 60 times a second. That's why you get the hertz. And they actually use, every time it crosses the 0 point, is what they call a sync pulse. Now, unfortunately, there's only voltage protection on the positive half of the waveform. So if you have a derailment and a short circuit on the negative half, it actually stays short circuit until it comes back around. Now, I know that's pretty fast, but that's still a lot of current that can flow. Anyhow, usually what happens is these transistors down here fail. And you can see it's a nice big heat sink. Now, according to trainfacts.com, his description shows it is an STP33N10 MOSFET. And if you go and Google that, you get a data sheet, and of course this is from ST microcontrollers, and it says it's obsolete. But I don't have those transistors. I have a different transistor. I actually have an IRF540N. Of course, that has a super low RDS on, 44 mega ohms, has 100 volts and 33 amps. Okay, so according to trainfacts.com, he has some theory in here, and it talks about the FETs can be tested with a digital ohm meter. Connect the ohm meter between terminal A and the center pin of the 3-rail pin and set the meter to diode. Similar for testing the junction. Now, on here you can't see, but actually this is A. The center pin of this 3-pin Molex connector is actually what Lionel calls the hot, and then the bottom is what Lionel calls the U. So, my multimeter, let me just grab my leads. That's set to diode. And he says if you put if the red lead is connected on pin 2 and the meter reads about 550, Q2 is shorted. So we'll put connect ohm meter between terminal A, which is this left one, remember, and the center pin, and we get 0.492. Now with the center pin and terminal U, I get nothing. And let's flip them. And the black lead, and then terminal A, I get nothing. And then terminal U, I get nothing. So, to me, well, the way I look at it, and according to train facts, it says if the red meter lead is on pin 2 and the meter reads 550, Q2 is shorted. If the meter lead is on pin 2 and the meter reads 550, Q3 is shorted. If the meter reads near 0 for both polarities, both FETs are shorted. So, anyhow, appears to me Q2 is shorted. So, if I take it apart, and I'm actually going to put it on my continuity so it'll buzz at me, and if I probe this one, which is Q3, the outer rails, I get nothing. But if I probe this one, which is Q2, which is supposed to be bad, you see there's continuity on the 2 outer rails, which is the, on my other paper, those outer rails are actually the drain and source. So this FET here is bad. Now, as luck would have it, I do not have an IRF 540N. I do have an IRL, and the IRL is pretty similar. They're both 100 volts DSS. This one's 36 amps, this one's 33. The IRF is only 33, so that's okay. But the huge difference is the RDS on. This is 0.044 ohms, and this is for 44 mega ohms. And as you can see here, Lionel felt like heat was a major factor, so they have this huge heat sink. And there's no ventilation or any active cooling, so I don't want to go that route. So, quick trip on eBay, DigiKey, whatever your favorite part supplier is, and I have ordered some IRF 540Ns. So what I'm going to do is buy them and replace them. Now, as you remember, I only said this one is bad. I'm going to replace both. If I'm going to go through all the work of taking both of this whole heatsink out and those 2 chips, I might as well replace both of them with 2 brand new chips, and that way I know for 100% sure both of those 2 are good. I think the other thing I'm going to do is, according to the data sheet, not the data sheet, excuse me, according to the schematics by Mr. Bickle, it's saying that there's a diode and a couple resistors, and I'm going to get in there and just check specifically these 2 diodes. I mean, these are 1N914s, very common diodes. I might even just replace those just as a matter of course. I mean, I'm going to get in there and remove these FETs and heat sink, and now while I'm in there, I might as well change those. I have these in stock. And the same with these resistors. I'm going to just check these resistors. Again, very common values, 10K, 20K, 82K, 10K, 20K. So I have all that stuff in my parts bin, so if I need to change these, I can. The other thing I'm going to do is I'm going to install the varistor. And on the train facts, he talks about, what the varistor does. Or, excuse me, not a varistor. It's called a transient voltage suppressor. So it's on the board. Lionel felt the needs to design it. Let me get you a closer shot. You can just see the outline there just below that green capacitor. It should say VR2. That is where they're actually supposed to put it. Why they didn't put it in there, I don't know. They designed it to have. I'm going to take these FETs off. I'll have easy access, and I'm going to go ahead and install a transient voltage suppressor. And he recommends using a 1.5 KE 36KA. So anyhow, I have some transient voltage suppressors in my parts bin. I'm going to use whatever I have, because certainly having something is better than nothing. Alright, couple notes when you're doing this. Take your crystal out so you don't damage that. The other thing you need to be careful of is these 2 wires here. These are the antenna wires for the TMCC control, and you just have to be careful. I went ahead and just marked which one went where. I don't think it makes a difference, but just in case, because I'm sure with twisting this in and out, I think I'm just going to desolder these now so I don't ruin this wire. Just kind of a side note, if you look down in there, there's a lot of compound on there. And these wires are really twisted. I'm almost convinced that somebody has been in here before and changed those FETs already. I can't say for sure, and according to what makes me say that, this is a picture. This is the only picture I can find on an internal one, and this is from the TrainFax Mr. Bickle. And we have this, even though we have the same one. This is Lionel PM1 Rev J. I have Rev K. So mine is actually one past his. I mean, there's a lot of compound on his, and then these antenna wires are nowhere near as twisted as that. So I'm almost convinced that somebody's been in there. The other thing is the capacitors look totally different. I mean, everything else is the same, but I'm almost convinced that somebody's been in there and they might have changed it. So anyhow, let me go ahead and take it apart and we'll go from there. All right, quick follow-up. Another thing I forgot to mention, in the TrainFax website, he talks about another symptom of a bad FET, where one is bad, is that you have either power from 0 volts all the way up to 12 volts but nothing else, or you have power down at 12 volts and then up to 18 but it won't ever go low. And that's exactly what I had. So here's just my test setup. So it's kind of a mess of wires, but I have a train on a track, 18 volt transformer. I actually had a couple different transformers too, and when I would put it on and I would turn it on, when I addressed the track with the cab 1 remote control, I would go right to 12 volts. So what I did was, I actually had the transformer at 18, I was measuring the voltage right on the track, it would go right to 12 volts, and I could get from 12 to about 18, but I couldn't go anything below 12. Okay, so how I'm going to attempt to get this apart, I don't really want to take this board off the front here, and unfortunately the Phillips screws are down below that. So I'm going to try to get this off by just loosening those nuts and then holding it and seeing if I can't run those nuts out. I can then take this metal heat shield off, and then I'll be able to get access to the underside of the board and remove the FETs that way. So what I'm going to try to do is use this 5.5mm socket on this long extension with a handle and see if I can't get this off. I thought this might be of use to somebody. Getting them back on should be fun. So there's the two little tiny nuts. Of course, I say I don't want to take this board off, but I have a feeling that's what I'm going to end up doing, is actually removing that board. Because I'm not sure how else I'm going to get access to all these parts. I mean, you can see there, these things are just caked in that heatsink compound. I mean, I guess it's quite possible it was that way from the factory, but... Okay, so now that I went ahead and removed the two antenna wires here, and what I'm going to do is just use this cheap little caliper and measure the height of these two transistors. So when I put the new ones in, it's not so difficult, because obviously I have these holes that I have to line up here, and I don't want to be fighting this and trying to hold them and solder them. So my thought is, if I put this here and I get the height, when it's time to replace them, I can use this as my template. And I think what I'm going to do is just take a piece of tape, take just a piece of electrical tape here and tape that around, and then as you can see now I have this a nice kind of height gauge, so when I put the new ones in, now I'm going to do my best to remove all this old solder. So I'm going to put a little flux on there and then use some solder wick and try to get all that solder out so they have nice holes to slide the new ones in. Now unfortunately I don't have any fancy desoldering tools, so hopefully this works well. Alright, so let me grab my little vise tool. Alright, so take my little brush, just put a little bit of solder paste there. And it's moving, it's just not going too well here. Yay, I finally got it out. Alright, so I'm just going to take a little bit more solder, or excuse me, a little bit more flux in there. And just run this one more time over top of those pads. Not sure if you can see, but three perfect holes. So now I can slide the new one in. Alright, so let's do the other side. Alright, so there's that one, and let's just do the same thing. We'll put a little more flux on here. Take the wick and clean the rest of it up. One little tip I'll give you for you know, kind of solder wick is don't be afraid to use it. I mean, I used a whole bunch trying to get it all up. I used to be very stingy with this stuff in the beginning, and it just never seemed to work because I was filling it up too quickly. And now you can see, I mean, there's perfect holes now. Alright, and just as a comparison, here's just a regular transistor, and you can see now these fit in there, no problems. So when I get my new ones, I can get them in there to the right height, kind of hold them in, and then I'll put a little solder, and that should fix this right up. Alright, so I got the new transistors in there. Use my little gauge here, and I'll set that on the base and get a good height, and that way I know they're lining up. Kind of bent the legs to keep them in the right spot. Slide into my jig here and solder it up. There you go, as you can see I got good solder joints. Just going to check and make sure the solder flowed to the top there. Alright, so we trimmed the legs, make sure it's cleaned up. Just check the joints here with the magnifying glass, make sure we're in good shape. And that's looking pretty good. The other thing I should note, if you can see down back here, that is the transient voltage suppressor I installed at that VR2 location. So that just goes from that pad there over to that R28 pad there. Alright, let's go ahead and get the metal heatsink and put it back on. Alright, one thing I'm going to do is just use a little bit of alcohol and acetone mixture I use I just call it flux remover here. It's just a bottle of acetone and isopropyl alcohol. I'm just going to clean the back of the transistors off so I can put a little thermal compound on there for heat transfer. And you can see I already cleaned the metal heatsink here. You can see how dirty that is. I just have a little credit card thing. I cut up an old credit card that has a little squeegee on it. And I'll just kind of squeegee it on the back here. You just need a little bit, just to fill in the gaps, not a lot. More is not always better in the case of the thermal compound. So I just moved up to my little plastic screwdriver tip thing, and as you can see now I got a good amount of heatsink compound on the back. So we'll stick that in and we'll just give these a little quarter turn to lock it in place. Alright, so there's one. Let's get that down hand tight. And as you can see, my gauge here worked perfect. Got me the nice height for where I need to be. We'll just kind of reposition that tape. And I think I'm just going to put a little bit of extra here. I think I'm going to change it up. I think I'm going to wrap the tape on the capacitor side and not on the heatsink side. Just as a little extra. Alright, there we go. You can see the screws are nice and tight. The new transistors are in there. Got a little bit of tape protecting the capacitors. Alright, I gotta put the antenna wires on. Now I marked which one went where, the little yellow dot, but I don't think that it's gonna make a difference either way. And so now I'm back in business there. Got my crystal back in, heatsink on, and I'm ready to bolt it back together here. Now on this lead, the red wire goes towards this side over here, towards this switch. Now I guess it would make sense at this point to redo my test, see if I get similar results as last time here. So I'm going to put my meter back to diode mode. And if you remember from earlier, it was A to the middle pin, nothing on diode, middle pin to outer pin, again nothing, and we'll flip them, nothing, nothing. So it looks like we're in good shape. Alright, so I am going to just temporarily put this on here and then get it all set up and test it prior to completely reassembling it. Okay, so here's the test setup. Just a regular old Lionel conventional train on a test track here. You can see right there. I have the repaired PowerMaster. It's a small transformer for testing. Some small alligator clips connected to the transformer. This goes to the track. I have a voltmeter there which measures AC current on the track, and then the cab with one remote. So we'll give this power. You can see the green light comes on. It's programmed as track 1, so we'll address it track 1, and then we'll slowly advance it. As you can see, the lights came on and we're at 2.6 volts and it is moving. Hit the bell button. See, I get the bell. Also in the background, the red light is flashing for the command. You can see now I'm in neutral, and we'll run the wheel here, and if you look at the voltage, I'm at 12 volts now. Now before I fixed the transistor, the symptoms I was getting was I would have when I hit the halt button or the emergency stop here, if I hit it now, you can see it kills power to the track. So I go to 0 volts and then the lights go off in the cab. Now before, when I did that, it would only go down to 12 volts. And in the brochure from Train Facts, he talks about if one transistor is bad, that's actually what will happen. So I was fairly confident based upon my test that actually is what the problem was. So we'll bring the throttle back up. As you can see, we're going backwards. We'll hit direction, and again, and it'll go forward. And there you have it. One repaired Lionel PowerMaster. Alright guys, well hopefully this was useful to you. Please remember to hit that like button down there below and subscribe for more great how-to videos.